Hello and welcome to the bridge hacking presentation. Probably you have already seen many smart contract solidity-based hacks and vulnerabilities and exploits, but what the hype now is the bridge hacking. If you look at the last couple of major breaches in cryptocurrency space, you will see that most of them are related to the bridge systems. So I thought this will be a good idea to bring it here and talk about it. This presentation has three parts. The first part is about explaining how bridges work, how they connect blockchains together. The second part will be a demo where I show you how you can use a bridge and show you some tools which you can use to hack them. And also the third part, and in this part I will speak about a few other recent bridge hacks and how they were breached and how it could have been avoided, and hopefully we will learn from the lessons, though in InfoSec we know that this doesn't really happen. But yeah, let's jump into the fun. So why would you do this Web3 or bridge hacking anyways? Well, you can hack money directly, because the difference in cryptocurrencies and this new Web3 space, even though most people consider it as a buzzword and we see many other buzzwords around it, the thing here is that the native payments are in the system, so you do not need to play around with bank transfers and credit cards and this kind of things when you want to move money. So from attacker perspective, this is super convenient. Once the funds are taken, this cannot be chargebacked or refunded or whatever. It's gone and that's it. So but let's have a look quickly what kind of knowledge we need to hack bridge systems. Basically, when you start reading and learning about cryptocurrencies, then you will see a lot of buzzwords popping up. In this slide you see some funny words there and a collection of those that are related just to the bridge hacking. Stay with me, it won't be too long, and we get through the explanation of what is what and why this is need to be understood to understand the topology of a bridge and how the system works. So first of all, let's see what this Web3 buzzword is. Let's reverse engineer it. Web3 appeared as a term as the read-only web. Then Web 2, yeah, let's say that Web 2 is the commercial, monetized, enterprise, centralized, and yeah, at least interactive web, which has some issues regarding privacy. So that's Web 2, which we know today. And then the term Web 3 was born, which is meant to be trustless. It has meant to have this native inbuilt payment system, like coins. You can think about Bitcoin or Ethereum. It is meant to be also decentralized, self-governed, and you want some other nasty words, maybe distributed or verifiable, just to have a full picture there. But it looks like that we are really far from the fully Web3 world. We are more likely in an era where we are Web 2.5, because nowadays Web3 systems are built in a way in cryptocurrency related terms that we are using centralized parts in it. And basically, bridge is one central part between multiple blockchains. So the bridge connects them together with the standard Web2 setup, where you have front end, where you have the back end, and APIs, and talk with other kind of systems. So let's have a quick look into the term blockchain, what it means. The blockchain in itself is a growing list of records. These are the blocks, they get hashed, and then in the next block there is the hash of the previous block, and then this goes on. And that was the original idea. But now in this presentation, when I will be speaking about blockchain, I will mean that blockchain with this basic capability, plus the peer-to-peer protocols, plus the consensus algorithm, plus the EVM, which lets the smart contracts run. So that's one blockchain. And that's an example, for Ethereum, where you have EVM. That lets you run the Solidity-based contracts. So the solution of the bridge is simple. You have coins in one blockchain, you have coins in another blockchain, and you want to make an exchange between the two. What do? You have a centralized system that now we call bridge. You send bitcoins from your Bitcoin wallet to the bridge. Let's say we are doing it with bitcoins and we want to have Ethereums. So you send the Bitcoin to the bridge, and then the bridge will send you Ethereum on the Ethereum chain, and you specified it. So it's basically kind of central exchange kind of thing. But what is added in those systems and what tries to make them less complicated, let's say, is the use of smart contracts and the wrapped tokens. So what is a wrapped token? A wrapped token is basically presenting the token value of the main coin on another blockchain. And let's say you have wrapped Ether. You have Ethereum, you have another blockchain which runs smart contracts, and you create a smart contract, you code it in Solidity, and you say, okay, now we call it wrapped Ethereum. And you create a bridge, and when someone sends Ethereum to this bridge, you send a transaction on the other chain and say, okay, now I approve the same amount of wrapped Ethereum on that network. And you can start already thinking about issues, what can go wrong, for example, in a case where you have not just two blockchains participating which are connected by one bridge, but multiple of them. What can go wrong? Well, let's move on to our first case, which is the Banano bridges wrecked. So I told you in the beginning, I will bring you a fun example. Banano is a cryptocurrency. It's a meme coin, just like Dogecoin, and they also have a bridge system running, and they were also breached like many other projects. They recovered in kind of nice ways. There were no users affected in the breach, fortunately. And this is a topic which I think is really good for beginners, because this showcases how bridges works. You can play with the whole thing around. It is not expensive to use it, because for example, if you want to play around with Ethereum on the mainnet, that will be super expensive, or you run your own systems. But here in Banano, you can play the whole thing around for literally cents, and you can do real stuff on real bridges. How does it work? So now we have the Banano blockchain with the BAN coins. We have the smart contract on Polygon, which implements the wrapped tokens on Polygon. And we have another smart contract on Binance Smart Chain that implements the the smart contract on Binance chain. And now this state which I'm explaining is the state from the hack. So there might be some new features coming, or some features are already out there which are not listed here, but now I'm reflecting on the hacked infrastructure. And then we have the standard Web2 servers, the bridges for both sides. So it pretty much explains the situation, and if you have done some web penetration testing and you have heard about replay attacks, then you can guess what happened here. So first of all, the Bun team realized that there are too many alerts on the bridge, and the hot wallet, which is the wallet of the bridge, needs to be refilled. So normally a bridge should have no access to the full balance of the coins or the smart contract balance. What it does is collecting the funds and giving out receipts. The receipts are used to mint, to create the tokens on the smart contract. And now you can pretty much guess how this vulnerability was exploited, because the guys figured out that these two Squidroad and Alibaba attackers looted 600k bands, 15k at that time, but some of them were returned by Squidroad guy. And yeah, so it took a couple of days until the guys realized what is actually happening. So it was not just like, oh, we have empty balances and now we know what's going on. And they found a fix. There are at least three ways on how to solve such an issue, which I will explain in this third part of the talk. And yeah, the attacker, one of them, returned some buns, and we learned a lot about this issue and how people who are not deeply technical, I would say, can still exploit a bridge, and you don't even need to understand how ECDSA work and how you exploit more complex cryptographical issues. Sometimes you just need to do some really simple thing as the exploit. First, let's have a look into a transaction and how it works. We need to look into this because as most of the hacks in blockchain systems, then you need to do some transactions, so it's really kind of key concept to understand. So now we want to communicate in this example with the smart contracts which are running on an Ethereum based system. So when we are speaking about Binance Chain, Polygon, or Avalanche, they have one thing in common. They are kind of Ethereum forks, and all of them implement EVM, and EVM is the Ethereum virtual machine that executes the bytecode that you probably compiled from Solidity, or yeah, there are some people who use Viper as well, but Solidity is the most common one. So how do you interact with the smart contract? First of all, you need to prepare the transaction. You need to fill the fields who you are sending to, the values. You need to specify the gas, which is a system that keeps the execution not overloading the system, protect against those, and figure out the values of how much execution is needed for a specific request or a transaction to be mined. So when you have the whole transaction, you sign it with your private key. For example, if you have a MetaMask, you use web3.js to create the transaction core. You sign it. You either use MetaMask Infura provider, which is inbuilt, and broadcast the transaction through it to an Ethereum network, or you might have the Ethereum node running and you can broadcast your transaction through your Ethereum node. Then it gets propagated, and after if everything is correct, of course, so this is checked that that your transaction is correct and mineable, executable. Then if everything is working, it is propagated, mined, and then you get your notification or transaction status back, which tells you that it succeeded, and yeah, you can move on and your request is basically done. For this, most of the time nothing else is needed to send or propagate the transaction than HTTP and WebSocket. That's the two most common protocols that we see here. Okay, so what did the attackers call in this example? So what were the Banano hackers doing? If you look at the Polygon Scan and the Binance Scan Explorer, you can find a link in this slide. I will share you the slides later. Then you will see a mint with received function and the following method ID, and this is the example. This is the data that was signed and sent to the smart contract, and the attackers just did one thing. They basically copied the same function call from one chain to another, and because the two blockchains are totally separate from each other, they cannot communicate with each other. They cannot check, okay, interesting, this receipt has been used already in Binance, so please don't give the wrapped tokens to this address on the other one, and don't let this receipt be accepted. A short explanation on what's going on. Function, you send a recipient the amount, you specify the UID and also VRS for the ECDSA assigned data. So this VRS is actually coming from the bridge, and the bridge is giving you the receipt there. So the only thing that attacker did is to use this same TX on both chains. Of course, you had to modify some fields in the transaction so it matches the smart contract address, because the smart contract address is different on the other chain, but you pretty much didn't have to tinker. So you didn't have to tinker a lot to make it happen. So in the next couple of minutes, or maybe 10 minutes or more, I will show you a demo on how this bridge works and how you can send your transactions and how you can tinker with them. There are a couple of base tools which we use, and I think everyone who is getting started with hacking bridges or hacking Ethereum generally you should know about. So yeah, Firefox, MetaMask as your wallet, your Ethereum system you can download Get if you want to play around with an Ethereum node locally. But if it's too large for you, then you can use Ganache, which you simply run and it pops you up a full Ethereum based blockchain, so it's pretty simple to use. Then you can connect to Ganache, make transactions and so on. Truffle or also the Remix IDE, both are fine. Truffle is better for making tasks automated, and for example you can write some exploits or some more complex stuff in Truffle. You can also connect Truffle to Ganache, so this pretty much gives you a starter setup to do the bridge hacking. In most cases, surprisingly, this will be enough, so you don't need to overcomplicate things, and that's the beautiful part in it. So let's have a look at the demo.